My name is Widdershoven, and I'm a Java engineer and software architect for the Java cluster of Capgemini in the Netherlands. I get really motivated by things that scale. How do you create scalability in your environment? From a technology point of view, this is of course super interesting, but also from an organizational point of view, how do you make sure that your development teams, that you can add development teams without bogging down in communications? And it is actually fairly easy. You just have to reduce dependency and constraints. You have to move away from asking permission beforehand, but instead implementing a system of roles that give you permissions to do whatever you need to do, like creating machines, but also have all actions being logged as an audit trail as a side effect. So automation is key in this endeavor. You have to trust people to do that they do what they are supposed to, and you have to be able to check it, and you have to do that automatically. So if I look at technologies that really motivate me to work with it, it's like, for instance, Apache Kafka. Apache Kafka allows a very clear separation between producers and consumers. It is GitHub and GitLab. They allow every action to be registered so you can go to production without having everything checked by a third party, because everything is so auditable and because you got permission beforehand. We will, of course, be using Spring Boot because, for a microservice, Spring Boot has integrations to just about any system that exists in the world. So it allows you to have production-grade code with not that much of effort. You will see that in the demo where we will connect to the Vault. And last but certainly not least, I really like the cloud environments. You can, of course, go at the infrastructure level, like virtual machines and Kubernetes. And it really also already allows developers to just develop by not having to apply for new hardware, by waiting weeks for permission and stuff like that. But if you really want to go fast, then you go, of course, to the managed services. Think of Cloud Foundry, Heroku, but also Google App Engine, Google Cloud Run, Azure Application Service, App Service. These things enable you to do whatever you want to do without waiting. And as you might know, I really like the scalability, this thinking about technologies, not just how they work, but also what they enable you to do. And you will also see that in this presentation, that it's not just about the technical implementation of properties and what kind of systems you can use, but also what it means to choose a certain system. So that is from my business side, from my work side, that I really like. But on the other side, I also like fantasy and I like science fiction and reading books, science fiction books. I like playing computer games like Kerbal Space Program and Factorio. And yes, these are mostly like programming, but differently. And I like watching documentaries. But enough about me. Today I will be talking about library Spring and Spring Boot. The title says Spring Boot, so I have to talk a bit about it. And of course, we're using Spring Boot. I'm a Java developer. How can you not use Spring Boot? And we're going to use the same mechanisms that underlie the Spring Boot system. So we're going to talk about Spring Boot, how Spring Boot differs from Spring, and what libraries, how libraries fit into this. Then I'm going to talk about configuration in various ways. What are the types of configuration? What are the property stores? What is the context in which you need to evaluate, and how to make a choice. And then we're going on to the demo, in which I will look at pieces of code and show you how you can work with properties. How do you get values in there? And how do you use the values? And at the end, there's a summary. But let's get started with Spring Boot. If you look at the green triangle, well, you can hardly miss it. At the bottom, there's this non-Spring libraries. These are things like the JDBC SQL driver to your database, like, is it MySQL? Is it Oracle? Is it Postgres? Is it a Redis driver? There is tons of software out there that connects to some system, and it's not Spring. What Spring adds is an container, of course, the auto-wired stuff. It adds lots of facilities. But what it also adds is a uniformity, a certain consistency. Systems that are conceptually the same look also very similar in the APIs that Spring offers. If you look at the database, of course, JDBC itself is a spec. But if you look at how Spring Data JVA abstracts this again, and with the transactional annotations, with exception translation, Spring makes all kinds of things look uniform. And even when you go to NoSQL databases, like MongoDB, it looks very, very much the same as the SQL does. So Spring adds a bit of consistency. It also adds a billion options. You have all sorts of classes that you could instantiate. Should you? Who knows, right? So it's not really that fast to build a Spring application from scratch. There's a lot of effort going into thinking about what do I want, what is normal, what is consistent with the rest of the world. And for that, you have Spring Boot. Spring Boot is built on top of Spring, and it adds some high-level components. But what it mostly adds is common sense in the form of convention over configuration. So if you have the Spring Data JPA module and you have the PostgreSQL driver, Spring Boot assumes that you probably want to connect to a Postgres database somewhere and use the JPA API to execute SQL on it. That's a very logical assumption. And it will have a best of breed configuration for that setup and create it for you, unless you ask it not to. What is the trick with this kind of auto configuration is that by default, it is almost what you want, but not exactly what you want. And that is why we have the configuration. We can configure the things that are different. And you can do that in Spring Boot in two ways. You can do it normally with properties, in particular things that often change. Username, password of a database is something that is really not a default normally, hopefully, but also the URI, where does the database live. You configure those through properties. Connection pool sizes, you can also override through properties. Spring Boot also has other mechanisms like conditional or missing bean and stuff like that, which we will not be talking about. This is not about a generic Spring Boot configuration mechanism. We're just going to use properties. But we will be using the same mechanisms that were designed for originally Spring and extended for Spring Boot. There is still innovation going on into the property system. Just, I think, with the 2.4 release, they added the ability to add multiple profiles in one properties file, for instance. So this is still actively being used, even if properties seem to be, well, the most simplest thing on earth within the Spring ecosystem. So sure, that is Spring Boot. About this talk, a bit more focused on the next section, is how do you configure using properties, the types of configuration, the types of configuration stores, and your context. The types of configuration is like, what do the values mean? The types of configuration store is whether you park them while they are not being used, and how do you give them to the application. And your context, well, whether you have fast deploys or slow deploys, actually matters when making a choice. And ultimately, there is a beautiful decision matrix that combines these in color. What types of configuration do we have? Well, we have constants. We all know what a constant is, even though a constant is not normally constant. But if you think like your application name tends to be constant, the name of your company tends to be constant, the address of your company tends to be constant. But with an address, is it really constant, yes or no? So there's some kind of volatility involved when thinking of constants. But yeah, constants, we all know what a constant is, but it can be configuration. You can configure constants. You also have tuning parameters. They tend to be fairly technical, things like thread pool size or timeouts. Connection configurations, how is the catalog service called? Where can I find the order service? Business values, well, highly volatile business values tend to be stored in a service somewhere. But the things that are really actually fairly constant, like that, it does change. I mean, a few years ago, and now it's 21% here. So they do change, but it's not that fast. So you can configure that. You have feature switches. Which features do the customers get at this moment? And which, well, do they not? I mean, is it still in a pilot? Yes or no? So that's kind of feature switches. And you have secrets, which are not properties at all. But that is a completely different side. You need to have it configured, but it's completely different than something for which you want to know the value. So let's look a bit more in depth to some of the characteristics. Constants, they hardly ever change. That is kind of what makes it a constant. Tuning parameters, when I think of tuning parameters, whatever it is, it's typical that you, the DevOps team, decides the value. If we have a separate dev and a separate ops team, then it might be the ops team, but I'm now assuming a DevOps team. So you, the DevOps team, decides on the value. Connection configuration, these are also your values. You at least know what they should be. They are in your power to change. But if you're talking about VAT, business values in general, you have no say in the values. You just get told, like, make it so at this moment in time. So the ownership is completely different. Yeah, feature switches are kind of the same. They are more business than technical in nature. You as a team can talk about a feature, but the business will probably decide whether they want to have that feature enabled for the consumers or not. And these kind of considerations come into play when you choose the right way to interact with where to save the properties. And last, but certainly not least, it's secrets. Secrets are not properties. I mean, technically they are values that you inject in your application so that it can do its work. But you don't care about the value of a password. It needs to be the right password. If I look at the configuration of my checkout service, and I see there is a URI catalog.services.capgemini.com, I can see it's wrong. The value is just wrong. A thread pool size of 10, maybe it's a lot, maybe it's not, but it has a meaning. A password of top secret, the only thing that says is that I have a really bad taste in passwords. So the password in itself has no meaning. Signing keys have no meaning. You also deal with them completely different. The governance is completely different. A property, you normally save it and you don't want just anybody to change it. But who cares if somebody knows that your thread pool is 10? Sure, it has some slight technical risk if somebody knows what the timeouts are and trying to overload your system, perhaps. But in general, it doesn't really matter. When you're talking about secrets, once your database password is out in the open, you have to reset it. It has to be secret. That's why it's called a secret. So the governance around it is completely different. From properties, you want to know when they are changed and when they are applied. From passwords, you want to know when they are accessed, when they are used. So the systems you would use for secrets are completely different than the systems you will use for other types of properties. So that is the types of configuration we have, and they have completely different characteristics. And because these things have completely different characteristics, you have different solutions. First, well, you can save your stuff in code. Constants you can put in code, but you can put just about anything you have that is yours in code. And whether this is actually in code or whether it's an embedded file, a file in your artifact, to me, it's more of the same. If you deliver a container, then the files within that container are part of the artifact. So that would be an embedded file. The properties, the application properties in your Spring application, the resource directory, would be an embedded file. So those are types of configuration stores that are in your code, but it is a valid place to put your configuration. A local file, well, if you deliver a container as an artifact, there are no local files as such. But if you run a virtual machine with Tomcat as your setup, then local files are actually a fairly resilient way of injecting properties. Normally, when your container starts, the configuration system must be online. If you have a highly available environment, that means that your property system needs to be highly available. Otherwise, your entire system is not highly available. But if you can have a local file setup and just dump the file every 10 minutes, as long as the property system is up, then if you have if you need a restart, well, there is at least a version of the properties that is fairly recent still available. So local files are a valid setup. You have environment variables through which you can override properties. The problem is, in that case, is not so much the environment variables, but how do you configure them and how do you manage what comes into the environment? So the governance around how do you manage the environment? If somebody calls you like the system broke down, how do you figure out what was in the environment at that point in time? So that is kind of the trick with environment variables. Well, there are also property stores, things like console, HashiCorp console, and every cloud provider has their own. AWS parameter store, Google has something, Azure has something. And you have, of course, Spring Cloud Config, which is, I think, uses a Git storage as a backing store. The nice thing of all these stores is that you know who changed what at what time. And we go to the things for passwords, and which is a vault. Vaults from the outside look very, very much the same as a normal property store, as all the property stores. They are, however, built completely different. I'm not going into the details, but everything is built around keeping stuff secret, obviously. But also on other thing, who accesses the properties. And if you look at HashiCorp Vault, and unfortunately Brian is ill, as Natalie told you, but Brian, I think, wanted to show a bit on HashiCorp Vault, a bit more than I would. But it has an option to just generate on the fly database accounts and passwords for you. So based on your own access to the vault, every time you ask it for a connection to a database, it generates a user by, of course, creating that particular user on the database and giving you the credentials back. And if you don't extend the lifetime of that account, it will also get dropped automatically. And this shows that the people who make such a vault actually understand the type of problem that they want to solve. And that the type of problem they want to solve is not the type of problem that property stores normally want to solve. So that is kind of the types of configuration stores. Now we go about your context, because this is all really nice. But the decision you need to take needs to be good for you and not good in general. There is not one ultimate solution and the rest is crap. There's just the solution that is best for you, for your use case. And I think one of the most important things to take into account is the CI/CD build speed. If you have a 15-minute build, I mean, then code is a perfect place to put your properties. Because if you need to change that in a property store and restart your application or reapply it, that's not much faster. And putting it in your CI/CD pipeline, in your Git, in your application, means that there's only one place to look if you want to know the state of the application. If something breaks for whatever reason, and you want to see did Leon touch the code again, then this is the only place you need to look. You do not need to look also in the property store or in the environment or in files or whatever. You need to look at one place. That is a real advantage, but it does require that you have a decent CI/CD pipeline. The delivery frequency is just as important. I mean, you could have a fast CI/CD, but if you only deliver once a quarter, which happens if you also install at customer sites, for instance, then you need to have the configuration externalized in some way. Another important factor is who owns the property value, who decides the value. And that is the same question as who owns the release process, because if you cannot decide to release yourself, then you cannot change the properties whenever they need to, and you possibly need an external store. You also don't want to have a build and get asked every time if somebody wants to change something that is not yours. Product prices, you don't put them in code. You'd get nuts having a release every time somebody changes the price of a product, the price of bread. It's also not nice for the other people. It's not nice for you, but it's also not nice for your business stakeholder. Well, auditability requirements, that comes also into play with CI/CD build speed. You want to know who changed the value and why the value was changed. It's not for a guilt thing or something like that. But if things break, you need to know what is wrong. And in order to know what is wrong, you need to know what is changed and who changed it so that you can ask that person, why did you change it? Can I revert it back safely, or is that an unsafe change? So auditability is also a really interesting requirement. And of course, secrecy. But I already spoke about vaults. So yeah, you don't want to share your PIN code. You don't want to have it just with a post-it on any wallet or something like that. So that is kind of the context. And now we go to the beautiful decision matrix. And I think you can already tell where you store secrets, in my opinion. It's always a vault. I have a demo in a few minutes, and Brian would have told you a bit more, but it takes about 3 minutes to put down HashiCorp Vault in a Docker container, have it configured, and have your Spring Boot application configured to run with it. It's not that difficult to do it right. And I have to say, for me personally, seeing those YouTube demonstrations, and they say that don't do that at home, and they paste a password in there with exactly the same amount of effort, they could have used a vault the right way. But okay, if you have a secret, put it in a vault. Then every time someone from security comes to you, like, what are you doing with passwords? How do you use them? You can say, like, I'm using a vault, which means that people thought about how to deal with secrets. The auditability is in order, so please go away. This is just the industry. This is what normal people do when they want to do it right. They use a vault. But if it's not secrets, how do you decide? Well, then you have the fast CI/CD. So that is if you have a build within 15 minutes. Quarterly releases, which is slow, and at customer, where you cannot actually do anything at all. And if it's like tuning parameters or switches or connections, technical stuff that you own, then if you have a fast CI/CD pipeline, you can just put it in code. Whether this is in the code itself or this embedded property file, whatever you want. Business values, you should just externalize somewhere, either in a property store or make a configuration service somewhere, particularly for your customers, for your stakeholders, but somewhere else. And for quarterly releases and at customer size, constants can be in the code, but constants have a different meaning when you go to slower release cycles, because I think you should define constants like does not change in the next 20 release cycles or something like that. And if your release cycle is once a year, then does not change in 20 years is kind of a hard thing to get or to guarantee. And if you have a daily release cycle, then does not change this month, tends to be fairly feasible. And basically, whenever you don't have a CI/CD pipeline, you probably should have all your properties that you do actually change in a property store, so that you can actually have a guide that tells people what to change and when to change it, so that they can actually access and change it. With Spring, of course, the big advantage is that Spring allows overrides. It is designed to actually have the defaults in the code, but if you want to, you can override it through a property store, for instance. So use that, and don't throw people a billion settings. Don't give people a billion settings that don't really change normally. Just give them the settings that possibly change. And one note about the Kubernetes config maps: don't use them for a Spring Boot application, and particularly for a Spring Boot application, right? You don't need them. The config maps, well, you don't need them if you are a DevOps team. If you are a dev team and an ops team, completely separate, then the ops team might manage the config maps and might like that more. But if you are a DevOps team, don't use the config maps at all. Put it in the application, because the only thing config maps add is overhead. You need to also figure out what is in the config maps. You need to have the config maps in Git or something like that and administrate them separately. They don't add anything useful when you use Spring Boot. Secret management, I would not store secrets except maybe service accounts. In particular, the service account for the vault, maybe the service account to console. in it. The secrets mechanism in Kubernetes is meant to transport secrets safely to your application. It is not meant as a secret management system. So Kubernetes has facilities and they are great, but they are not a management system. They are a more transport mechanism. So the demo, I'm going to start looking at the piece of code that you see here, the compute price. And I'm going to talk about constants there. And then I'm going to inject that values. Then I'm going to apply the configuration properties and tell a bit about the differences. I want to choose them. Then I'm going to change application and application profile properties to see how the override order works. You might actually know this already, but sure. Override something with an environment variable, add a property file through the command line, so externalize the property file, and then connect to the Vault and read the configuration tree from HashiCorp Vault. So I'm going to now switch over to my IntelliJ. Where is the thing? Share screen. And this is my IntelliJ. This is the application. It is a box standard Spring Boot application with one strange thing. I have all my demos in one application, and it is a lot of beans, and they are not all valid for demonstration purposes. So I activate and deactivate them based on the profile. And I chose, very uncharacteristically, to activate my profile in the code, because I like my stuff at one place, and that one place is the code. You normally don't put profile configuration in your code at this moment in this way. You normally put it on the command line or the environment, but this works for me right now. This is the application. This is the first piece of code I wanted to look at. It's the compute price. And we see that the price is rounded up, purchase price in cents, plus 10%, plus 21%. What does this mean? And that is the big question, of course. So why would you use constants? Well, this happens to be the margin. And immediately you see an incredible increase in readability. You, the experienced developer of this system, might have known this. You've worked for this 2 years, you wrote it yourself, so you know this is the margin. But this young professional who just arrived at your team, who doesn't know anything about your business, might be new at the company, has no clue. Just by giving it a name, you add 1000% value. So this is the margin. And you probably already know what this is, right? This is the VAT, 21%, can hardly be anything else. But I look at VAT and that's just not correct. This is not the value added tax. There is no such thing as the value added tax. What this is VAT high. It's the high VAT. We also have the 6%, I think, on bread. And now I look at this, the value added tax depends on the product. So by giving things a name, I think about it. I think about the business constraints on the variable, on the data. It's not 1.21. 1.21 does not make you think. Giving things a name, that makes you think. And now I see the VAT high in this case. I think like it's not going to change that often. It's probably fairly constant. But honestly, I don't believe that the margin will be constant. Maybe we get a competitor and the margin will probably decrease a bit, or the competitor will go away and the margin will increase a bit. So just by giving things a name, you can already predict the future a small bit. You can judge what is a constant and what should not be. And you can already talk to your business stakeholders like, yeah, is this actually correct, this 21% that are in the 6% tariffs? So this is what naming brings you. You can organize your naming, of course, a bit, your constants. And I bring this example up because the same holds for if you go to properties, you can also organize them. It's a matter of taste, but also you have one overview and maybe you have a few classes, constants classes for similar properties. So this is a choice you can make at some point to organize things. I don't think there's a right and a wrong, but some things, if you group together. Well, let's go to properties. This is the code from which I'm going to work. We just saw it. Now I'm going to make it configurable. And that is actually what Spring Boot helps you to do. If you don't do anything, it works exactly like the constants, maybe a bit slower, but it allows you to override the values from an external source without doing any change in the code. There is no high price for moving from a constant to a property, to in this case, an add value annotation or configuration properties. Whereas it does allow you to change the value whenever necessary. And it may not be that important if you have a really fast CI/CD pipeline, but in any other case, this is a super handy feature to use. Even if you don't require your customers to set the values, you buy yourself the opportunity to have it set when necessary. So this is how you would go from, instead of a constant, to a property. In this case, we use add value, which is a Spring annotation. Because this is a Spring annotation, this needs to be a component. With the add component, or add service, or add repository, or add configuration, all these annotations, you make it a Spring managed bean. You tell to Spring, make one of these for me. And just, if it builds one, it also auto-wires it. It looks at the add value annotations and sets the properties. So this add component is crucial to get these filled. In this case, and I told you when I discussed the demo application, I guard everything with a profile. A profile is a special type of property, not special in the sense of magic or something like that, but it gets evaluated in a particular way by Spring. And this, for instance, allows me to only create a bean of this type, an instance of BB example, when I have a profile called BB example. Or if I invert the condition, it will not be active when you have a profile BB example. This is a pretty useful property to have, the profile and the inversion, because you might have a profile dev environment, which is your laptop, a test environment, maybe some beans only should activate in the test environment, and a production environment. Or maybe a unit test, an automated integration test. Some beans should be swapped in an automated integration test. Who knows? But that is what profiles bring you. This, however, is not to talk about profiles, but about configuration properties. So we have this add value property, this add value annotation, I'm sorry, which is activated due to the add component annotation on the class itself. And what it does, it's going to evaluate this. And this is tricky because normally you would think, why on earth do we have these strange characters? Well, if add value evaluates this, you would get a class cost exception or something like that, because financial percentage margin is not in and of itself a valid number. I could have added 1.0 here, but something like that, but no. What this is a Spring expression language. So in the add value, this string is now evaluated as a Spring expression language expression, which is a programming language all of its own, and you can register methods in it. So it's really complex. But basically, this expands the value of this variable. It goes out and digs into the incredibly big map key values that are the properties, and tries to figure out what this is. And then it casts it to a double and inserts it here. And here you see the same with the default value. I'm not sure whether I have BB example as an example. Nope. I think the next one. this is the next one, which is exactly the same, right? It's the same code, but I did add something. I added a print line in a constructor to tell you what the value is of these properties. I injected into the lifecycle phase of the bean a post construct. So after Spring says this bean is completely valid, I auto-wire and stuff everything in there. This bean is ready for use. It goes out and calls after start in this case. I could name the method anything. It's the post construct that counts. But this is before the application is started. And I print this, which happens to be also just variables, the fields in there. And last, but certainly not least, I have the famous command line runner that you see in just about all demos. If the application is started, so all beans have been constructed and Spring has executed all post construct methods, then the application is started, and then our command line runners are being, well, collected and started. So I have one of those two. And this is also a Spring component, and it gets auto-wired. And this is what will be executed. So I'm going to run this. And my first question to you, I don't need an answer, but my question to you is what will happen? So let's just run. Yeah, I have an exception. I did expect that. Okay, and it is the exception I did expect. Could not resolve placeholder financial percentage margin. The reason for that is, and you can't know, but I have not actually configured this value in my properties file. I also have not configured it in my properties file for this particular profile. I also have not configured it in the environment. So that is the problem. In this particular case, I will choose to just add a default value. And this is a Spring expression language construct. It tries to evaluate this. If that doesn't work, it just returns this and casts this to a double or converts this to a double. So now you know that you do need to have a value, a default value. I could have done this, but that does not work for add value constructions. Because it is not actually the inserting of the value into the margin percentage that goes wrong, but it is the spell expression evaluation itself. Okay, so now we have a default. What do you think happens now? I'm going to print it in the constructor, at the post construct, and in the command line runner. What are the values in each of these cases? Well, I will hold you in suspense no longer, though I do doubt how much suspense there is, but we will just have a look. And indeed, in the constructor, the percentage is 0 and the VAT is 0 because it has not been initialized. In the post construct, it is by definition already set. And after start, it's still set. And in that post construct, I say by definition, because that is exactly what Spring says that a post construct should do. The bean is fully ready for use, including the add value annotations and other auto-wire stuff. The reason that the constructor does not have these values is actually very normal if you think about it from a Java perspective. If you want to have an instance of a class, you call new with the class name, and that calls the constructor, and then you get an instance, and with that instance, you can do stuff. And that is exactly what Spring does. Well, it does not have new because, or it does not execute literally new, but it uses reflection probably to do this. But it cannot circumvent the constructor mechanism. So the constructor, because that is called by Java, and only after that Spring gets an instance, which it can set the field values. So That is this one. Let's go to the next one. And this has to do with a bit of organization and constructor injection. What you already see is that I inject configuration and I print the margins from the configuration. And if I look at how I do this, I have a DB configuration class. And I have already set the defaults, which can be done here. And with add configuration properties, I bind the names to the environment, to properties. So properties that are called DB financial percentage margin, a property that is called like this, that value will be inserted here. If I cannot find such a property, then it remains 1.10. If there are properties DB financial percentage something else, that will just be ignored. So configuration properties binds the values. It provides the mapping from properties in the environment, the Spring environment, and your class. Then we make it a configuration. We make it a managed bean so that they can actually auto-wire it in somewhere else, because configuration properties in itself doesn't really do that much. And this is the Lombok at data, because I'm just too lazy to make getters and setters everywhere. They obfuscate what I want to say. So that is why I like Lombok. You only write the code that is necessary for your business. You do not write the boilerplate that just obfuscates your core feature. But yeah, so this is the construction that I'm going to use now. And this is also what I said, that you can, in a constants class, you can collect constants. This is the same mechanism, but then for properties. Instead of individual add values, you can group things together. You can have multiple configuration properties classes, even with the same prefix. Doesn't matter, it's how you want to organize them. Let's see. Yeah, I do have an example here. And I will just activate that profile. It is absolutely possible to have more than one profile active. But my code is not designed that way, so I think it would crash. So let's not do that. So what you see here is that magically that the DB configuration was injected, because otherwise I would have gotten a null pointer exception. And the values were available during construction. So for this one, and now we go a bit further. This is not really a demo, but this is what can you do with the add configuration properties? How complex can you make them? How far can you go? So you have this prefix, you make it a bean so that you can auto-wire it. Add data, or you write getters and setters, whatever you like. And in this case, for me, I use a profile to have multiple pieces of code separately in my application. In this case, I have a margin, but I also have a class. In this case, it's called vet, but it is a structured class. This class has fields of its own, and it has some Lombok annotations to make it work. It's a static class. In this case, it's not bound to the instance of EV configuration, but that's just my preference. And now I have EB financial percentage .vat.high. This is how I can configure such a class. This is a perfectly fine class with default 6% margin, a bit more limited than it used to be. We apparently have a competitor. 21% VAT, but I can overwrite it if I wanted to make a bit more profit. And if you want a bit more lifelike example, things that happen in real life, you're going to the request configuration. This is kind of, we all know how this works. Sometimes you have a connection to somewhere else, and you need to have a scheme and a host and a port and a path, and these properties, they belong together. Together, they describe one location, they describe one connection. So it's nice to group them together. So that's when a class in which you map them all is handy. It also has nifty features. There are converters that you can write yourself, but it comes with a lot of default converters for Java types. Duration, it can actually deal with duration by just entering 1500. You get 1.5 seconds duration, so it can convert between types. A proxy is also fairly normal if you have a connection, and a proxy can be enabled, host and port. Let's not go there, but yeah, so having a complex configuration is fairly normal. And these are things that you want to have grouped together, maybe with default values. You can make a base class with this stuff and have separate classes for the catalog service connection and the order service connection, and just have the class extend the base class and drop their own configuration properties with their own prefix in there. That way you have one piece of code, and you have a lot of nuance to configure your connection if you want to. This type of configuration, the configuration classes, configuration properties, is also what Spring Boot uses internally. I don't have too much now in this particular application on purpose, but normally if you just find a class and you also choose, and you just start typing and you want something with auto configuration in there, you'll find classes that use configuration properties. And that is one of the easiest ways to find out how you can adjust the configuration of Redis, your SQL thing, Geode, whatever you use. But this is a fairly easy way to find out what configuration is available. Okay, let's go to the somewhat easier, or not easier, but to the real demos in which I start to override values. The code things I've shown you now, but I have an add value, and this one is a bit more deeply nested. And I have configured my configuration class, and I just print the values on post construct. And this is my configuration properties class. So let's have a look. AC example. Let's enable AC example. And let's go to the properties, because I sneakily made my notes here. So let's first do nothing and see what AC example shows. And you see there is an add value 1 to both test. And this is important to note for the reason that this test value is also used here, value 1. AC example dot value 1 has no prefix. You also see it's null here. But if you look here, it's test, and that is because this evaluates to the default value test. The default value of the property AC example dot value 1 does not exist. What happens is that this gets evaluated. There is no such thing for the property. So the add value annotation evaluates to test. This property value will not be set to test. So it might be a bit subtle, but this does not change the properties. It just changes how it gets injected. Then we're going to override the value through, well, I think first should be the application of properties. And we expect test 3. And I see test 3, and it overrode the default values we just saw. I'm going to this one. This is a profile specific properties file. Spring will actually read application.properties just fine, but it will also read application AC example.properties and prefer the values set in there above what is in application.properties. And because you obviously don't believe me, I'm going to execute the demo again. But hey, look, I was right. The property has been overridden. Now I'm going to go with environment variables. So I need to actually build the code so that I can do it on the command line. I can also use an environment variables in IntelliJ, but to me that feels a bit less real. So let's first see what we have. I expect we have both the application properties and the application profile properties here. Yes, it's still test 4. Let's export the value. So this is how you inject things through environment variables. What is good to know is that there is no dot, but an underscore, because dots are not allowed in environment variables. But Spring does this also. Isn't it great? So test 5, we have it overridden. And I'm going to unset it, because otherwise it's going to play with my my next demo. So I have a demo a properties file here, demo.properties, and I want to use that. So I'm in the location from which I'm going to start my application, and my application itself is in the target directory somewhere else. Okay, well, I hope you're still listening. I think we may have connection issues, but I don't. So if I execute this now, you see it has changed, because Spring is going to also look for a property file with the application name. Okay. Yeah, there were some issues about connection problems, but maybe not. Okay, so this was the demo. If I have a file, applicational properties, in the current directory from which I start the application, then that will override the files in the application itself, in the jar itself. It does need to be named applicational properties unless I rename my application. That is also possible. So these were a number of demos just from our properties. And now I'm going to connect to a Vault. To do that, I'm going to do the Spring Boot thing. I'm going to connect to a fairly complex system with a very advanced API. And the only thing I need to do is just add a dependency. If I wanted to use database accounts with a limited time to live that you constantly have to extend, I could do that by adding an extra dependency here. Also a Vault dependency, but I think a Vault database dependency or something like that. And this is the power of Spring Boot. You don't need to do much for getting a highly advanced functionality. And this functionality, of course, you can configure using properties. There is one thing I inject through the environment variable, which is the token for my Vault. So this is kind of the username password that the application will be using to connect. And I do this, and this is fairly typical because you don't put passwords in code and you don't put it in Git. So you tend to inject that through environment variables or maybe mounted secrets in Kubernetes, something like that. What I do configure here is that I'm going to do it on localhost. It runs on Docker on my machine. And this is fairly new. It's the data config API. It used to go through the Bootstrap YAML. But these days you can actually have these protocols. And in this case, this protocol maps everything under secret my app to the properties in this system. So this is how I configure it. Let's think. Let's pick up the right profile. I changed the POM. I'm going to reload the POM to be sure. Then I'm going to run it. And I am really, really curious what happens. Okay, of course it worked. But let's look at the example code. This is a bean behind the profile. That's a normal component. It has secrets. It has default values. You don't see any default values here. So it apparently got a value from somewhere. And these values can have dots in the name if you want to. So they can be structured. I read the same values through configuration properties. In this case, I don't give them a root or a part of what they should read. I just have configuration properties so that it will map to the root of the property structure. And what you see is 2 strings and a type. And important is not the name of the type, but important is the name of the property for mapping the names. And this has a username and password. What is interesting here is that I'm going to get my data from a vault, which is a highly secure environment, but I'm going to fish out these values from the properties in a way that is exactly the same as any other store, any other property, any other location. And well, you just saw that it worked. So let's go to the vault. It's running in a terminal in a vault. I started the Docker container. When the Docker container starts, you can get the token. And this is in development mode, right? The production server is a bit more, well, a lot more secure. But the development server, you just export the vault token. Yeah. I went into the container now because that is where the configuration is, where the command line tool is. And I'm now configuring it so they can actually put in values. And I can get the secret, my app value. Secret my app is the property, and it has some key values in there. So it's a bit thinking this is not a property. Not everything is individually a property. The secret my app itself is a property. I could also have named it differently, but this is the name of the property. And I can change my property like this. And I can get it again. And you see that is now 1, 2, 3, 5. And this entire thing has a new version. And let's see if I run it, my application now. It should go 1, 2, 3, 5. Okay, I think that is the extent of the demo. I think the important thing to take away, the summary, is that you need to think on what to achieve before you figure out the how, because in Spring, the how is super easy. You have add value and add configuration properties, they both work. And it doesn't really matter how data got into the application. It's just how you consume it. So thinking about where you want to store the data, what are the constraints on that before you start typing is really important. The technology will not hinder you. It's understanding the problem that's more important. And of course, you can store your properties in multiple ways. I did not show them, but they are all basically the same. Well, I did show the property file. I showed the thing in the code, the environment variable, and of course the vault. But whether you use a vault, you use console, whatever property or other property store, or you make one yourself, doesn't really matter. They are all equally different, except if you make it yourself, that is slightly more difficult. But also not really that much, because ultimately it's just giving a map of key values that you got from somewhere to Spring, and it will handle all the rest. Yeah, and I think my closing remark is use a vault whenever the value is not public information. It is super easy to get into the habit. It's super easy to use. You don't need to have any discussion with the security team on how do you deal with the password and why is the post-it hanging there. If you have a vault, it is properly maintained and you don't have any discussions about it. It's also super easy, and that helps. So that's it for me. And I think I'm going to give the words back to Natalie, if she is still connected.
Yes, I am, Leon. Thank you for the presentation. And well, you said it was hard to match up to your last one, but I think you did. So thank you. We have a few questions. I think the first one you already answered, but how do you manage dynamic configuration when changes are applied without application restart? Like for the business?
Yeah. There's multiple ways, and it also depends on your context. But first of all, things that are often changing, like prices, are not actually configuration of properties. They come from a service, and you may or may not cache them if you can allow caching, or you need to think about caching validations. But they are not properties in the Spring sense. But sometimes a property like a connection pool could also be, well, not dynamic, but maybe you want not to restart your application. If you have CI/CD and you deploy to Kubernetes, it's just as easy, or probably easier, to deploy a new version, maybe with Canary releases or something like that, right? Running it in parallel, making sure that it all goes okay, and then that version takes over. I think Istio can do that for you. But if you have this quarterly release cycle, then that is not an option. And maybe your application is like huge and takes an hour to start. And in that case, I think Spring has a refreshable context, and it can detect changes in properties and apply them, and it restarts the context. But that is actually a restart, but the Java process does not get killed. So it's kind of in the middle there. It could help. So it really depends, and I think that is the baseline on what exactly do you want to achieve, and in what circumstances do you work.
Okay, thank you. Another question is about localization tags. Where do you keep your localization tags for the multilingual application?
That is not actually something that you do with properties. Internationalization is not something I know a lot about, because it tends to be done in the front end these days. But in the good old JSP days, I remember there were tags to deal with that. Java itself has really advanced functionalities to deal with localization by having a convention in the naming and indicating that a certain piece of text should be able to be translated. It can do that for you. I think it was the message bundle or something like that. So that is internationalization from a Java perspective. If you have it in JSPs or text, there is an API to deal with this. But if you go to the front end, it is more like, how do you know which package of languages to send to your Angular front end, for instance? So I guess I'm not quite sure how the question is supposed to be. You don't actually put text in properties in that sense. You can do it in property files, but these property files are meant to be used in a user interface, and they can have property files with underscore the language underscore the country, I think it is. And Java will pick the proper one given the locale you selected. Yeah, it's not really properties. It works the same, but it is not properties.
Okay, thank you. For me, it's clear. I hope it's for Chris also clear. Chris has another question. He says, keeping the configuration in the code violates the 12 factors app, right? And config can differ, and it will, between environments. Do you have any comments on that?
The 12 factors app, I don't have any comment on it. Mostly because I don't really care whether it breaks with some concept. I think that the purpose, if you have a fast CI/CD and you put your variables in code, you know the value. So you have this audit trace on the values come together with your code, so you always know what the application is, and it is overridable from external sources. I think, to me, that is the most important thing. But it varies according to environments. This is certainly true. And that is also why it is so nice that this configuration properties classes, I'm not sure whether IntelliJ is still shown, probably not, it doesn't need to be. But these things also have a post construct. You can actually analyze the injected parameters and choose. You can also have with a profile. a profile production, a profile test. If the environment for every Kubernetes cluster or whatever you deploy has one parameter in the environment that says which environment it is, you can use that as the profile and select the proper configuration properties. So one, you can have individual beans pre-configured for the environment, or two, you can calculate the expected configuration based on the environment you're in. We did it at the previous job, that we actually looked at what is the active profile. Oh, this is pro. That means that the URLs look like this. So yeah, they do differ between environments, but your properties can deal with that. And I would say it's actually really easy to read. But if they differ from the normal, then you would use external configuration. Or if there is not a real pattern to find, that also happens.
Okay, thank you. I got one question from René Kuipers. I don't really understand the question correctly. It was a follow-up question on the question of Chris about the multilingual application. René asks, and values that depend on the deployment environment in the decision matrix.
Okay. Yeah, if it's, I think I seem to remember that the deployment, the active profiles are being passed as parameters to the vault. It actually looks for a tree. There is, okay, if you look at the documentation of the Spring Properties framework, it's massive. It's really, really big. And the vault ties into that. And I think it actually gives the active profiles when requesting properties as an optional query parameter. That said, in your decision matrix, if you actually want to configure per environment, and you can deduce it in code, then you probably, well, I think you should do it in code. Maybe I should put it like that. At the customer side, you have no clue what the values are, and they may even differ in environments. And I think then it would be nice to externalize the configuration. I'm not sure whether that was the proper the answer to the real question. But I think it's the best I can do in this case.
I don't see any new comments from René, so if he needs more information, he has to be quick. Further in the comments, people thank you for answering the questions, and also from the code you shared on GitHub. We put the link in the chat, so if more people are interested, go grab it.
Yeah, don't get inspired by my Git commit comments. I truly feel that Git commands should be descriptive on why you did so, but I am afraid that I forgot to do that.
Well, I think we can forgive you for that.